earthquakes. Lane Ball has more on today's seismic events, all caught on camera.
The answer to that question is yes, but unlike the earthquake that shook the tri-state at the end of this past year, this one hit a little more than 50 miles away in Jackson County, Ohio.
A low-frequency tremor rippled beneath the rural soil of southeastern Ohio, shaking not just the earth but the foundations of current scientific understanding. At precisely 3:14 a.m., a strange harmonic vibration was detected near the town of MacArthur, nestled in Vinton County. Initially logged as a minor seismic anomaly, the readings quickly escalated in urgency as monitoring stations across the eastern United States picked up the event. But it wasn't the magnitude that caused the stir. It was the signature. The waveform didn't match any known natural phenomenon, nor any man-made source. What was happening deep under Ohio didn't just baffle local geologists. It challenged everything scientists thought they understood about the geological behavior of the North American plate. Before we start, smash the like and subscribe buttons for more updates. MacArthur, a town better known for its sleepy state forests and quiet hills, suddenly became the focal point of an international scientific frenzy. The epicenter was located not on a known fault line, but beneath a stretch of sedimentary bedrock thought to be geologically stable for at least the last 300 million years. Yet here it was, a series of pulses echoing at regular intervals, resembling more the rhythmic thrum of machinery than the chaotic stutter of an earthquake. The tremor came in waves, each lasting exactly 46 seconds, spaced precisely 3 minutes apart, over a 17-hour period. That level of rhythmic consistency in nature is practically non-existent. A team of seismologists was dispatched within hours. At first, they suspected underground construction, perhaps some kind of undisclosed military operation. But there were no bases in the region, no mining efforts, no pipelines, and certainly no industrial activity that could produce such synchronized seismic waves. As portable sensors were deployed around the epicenter, the team began to realize that the tremors were originating from a fixed depth of approximately 22.4 kilometers. That's far deeper than any commercial drilling operation has ever reached in Ohio. The lithosphere at that depth is hot and under massive pressure, not conducive to conventional tectonic slip. When the first ground-penetrating radar data came in, it showed a curious structure, a sort of circular cavity almost 1.2 kilometers in diameter, buried deep in the crust. It shouldn't have been there. The rock around it was smooth, undisturbed, almost as if the cavity had formed instantaneously. Even stranger, the cavity was radiating a low-frequency hum, imperceptible to the human ear but picked up clearly on instrumentation. Not magnetic, not gravitational, and not electrical in nature. Some likened it to the resonant feedback of a perfectly tuned glass bell, only on a geological scale. That's when the field measurements started registering fluctuations in the geomagnetic field around the site. These weren't spikes or bursts, but gradual oscillations, waves that ebbed and flowed with the same rhythmic pulse as the seismic events. Researchers from Ohio State University began cross-referencing the data with satellite-based magnetometers, and the results left them stunned. The pulsing signal was affecting the ionosphere directly above the region, producing transient pockets of charged particles in the upper atmosphere. These pockets were large enough to be seen by weather satellites as faint, flickering distortions, subtle but unmistakable. This opened the floodgates. Physicists, geologists, and atmospheric scientists from around the world began descending on the region, drawn by the sheer novelty of what was unfolding. The event had now crossed multiple scientific disciplines. Seismology, electromagnetism, atmospheric science, and even astronomy, as instruments used to detect gravitational waves were picking up trace interference whenever the Ohio pulses occurred. The signals were distinct and repeated, interfering with detectors thousands of miles away. Something in the depths of Ohio was affecting not just the local geology, but vast swaths of the planet's electromagnetic and even gravitational environment. Speculation turned wild. Theories ranged from natural geological processes never before observed to hypothetical deep earth resonators, massive crystal structures hypothesized in fringe literature but never proven to exist. Others proposed the idea of an underground cavity acting like a planetary organ pipe, producing infrasound waves capable of interacting with Earth's magnetic field. The problem was nothing fit perfectly. There were always inconsistencies, The frequencies were too clean, the patterns too persistent, the origin point too precise. Nature, as chaotic as it is, rarely repeats itself so uniformly. The most provocative finding came from a team that analyzed isotopic signatures from gas samples collected at the surface near the epicenter. These gases, mostly argon and xenon, bore isotopic ratios inconsistent with known Earth sources. In particular, the xenon displayed a signature reminiscent of that found in ancient meteorites, an indication that the cavity might not be naturally formed at all. The possibility emerged that the object or structure causing the disturbance wasn't geological, but extraterrestrial in origin. Deep-bore thermal imaging provided further intrigue. Beneath the cavity was a heat signature, not random or diffused like magma, but a perfect hemisphere of uniform temperature, anomalously warm compared to its surrounding rock, but not hot enough to be molten. It was as if a solid body of unknown material was resting there, absorbing heat and distributing it evenly. This thermal uniformity confounded experts. Natural geological bodies, even crystal deposits, don't maintain such perfectly balanced temperature gradients under pressure. Meanwhile, animals in the surrounding region began to behave oddly. Migratory birds rerouted from their usual flyways to avoid the area. Deer avoided paths they'd used for generations, and some domestic animals, particularly dogs, refused to go near the forest's edge. Ultrasonic recorders picked up constant low-frequency noise in the area, consistent with subaudible vibrations. Vibrations that, although inaudible to humans, could easily affect animal behavior. Curiously, humans in the region began reporting unusually vivid dreams, many involving repetitive imagery of circular patterns or deep tunnels. Though anecdotal, the consistency of these reports raised eyebrows among neurologists. While the phenomenon continued, attempts to drill closer to the structure were quickly abandoned. Not because of danger, but because every effort to penetrate the rock near the cavity failed. Diamond-tipped rotary drills dulled faster than usual, and the rock itself seemed to resist breaking. It wasn't a different kind of rock per se, but rather rock that behaved differently, absorbing energy from tools without fracturing. Engineers described the sensation as trying to drill through rubberized granite. This was not just frustrating, it was unheard of, as if the material had been altered by prolonged exposure to some unknown energy. Spectrographic analysis of surrounding rock shards revealed minute changes in crystalline structure, shifts in atomic spacing that could only be explained by long-term exposure to high-frequency vibration or energy fields. The most curious aspect was the alignment of microscopic particles within the rock. In normal circumstances, mineral grains are randomly oriented, but in these samples, they aligned in spiral patterns like miniature galaxies frozen into the stone. It suggested some organizing force, something that influenced the very atomic lattice of matter. To further complicate matters, the area directly above the cavity began experiencing anomalies in GPS positioning. Devices used for surveying showed gradual drift in coordinates over time. Not enough to disorient hikers, but enough to disrupt high-precision farming and construction tools. This wasn't typical atmospheric interference. The GPS satellites themselves were fine. The signal in this zone seemed to bend, as if space itself was subtly warped above the anomaly. Gravitational lensing on a minuscule scale was proposed, a terrifying implication because it meant that mass, energy, or both were distorting space-time locally. The implications of the event are enormous. If the cavity is natural, then the Earth harbors processes far beyond current geological models. If it is artificial, then the question becomes who made it, when, and why? And why is it only now beginning to interact with its surroundings? Perhaps it's a long-dormant mechanism, triggered by changes in magnetic polarity or tidal stress. Or perhaps it was never dormant at all, only undetected. What disturbed scientists the most wasn't what they knew, it was what they didn't. Every discovery only deepened the mystery. Every layer of data contradicted previous theories, forcing teams to abandon entire models and start over. The rhythm continued, never changing, like a signal waiting for a response. The pulses reverberated across the crust and echoed into the atmosphere, whispering a secret no one could decipher. The global scientific community is now watching Ohio with a kind of reverent awe. The region, once just another dot on the map, has become a focal point for humanity's understanding of the Earth and possibly the cosmos. The instruments remain fixed, recording data around the clock. Satellites remain in geosynchronous orbit, watching for any shift. Nothing has escalated yet. There has been no explosion, no collapse, no sign of emergence. Just the steady beat of something beneath the surface. Weeks passed, and the pulses remained unyielding in their rhythm. With every passing cycle, more layers of enigma began to reveal themselves, not by way of answers, but by presenting fresh questions. The tremors were no longer isolated to seismic instruments. Faint acoustic vibrations were now being picked up by highly sensitive hydrophones in distant reservoirs, hinting at their propagation through subterranean aquifers and underground water channels. What startled researchers most was the nature of the signal's persistence across different mediums: solid rock, water, and even air. This wasn't just seismic energy. It was something else. Something with the capacity to inhabit and travel through disparate materials with minimal degradation. Within research centers, the focus shifted to the harmonic qualities of the pulse. Acoustic physicists discovered that when the waveforms were converted into audible ranges and layered upon themselves, they created what sounded like an intentional tonal architecture. Notes formed chords, chords formed progressions. It was as if the pulses were not just mechanical repetitions, but encoded with patterns, something bordering on syntax. Could this be a language of sorts? An ultra-slow form of communication that had gone unnoticed for eons? This speculation ignited a new field of interdisciplinary study, where linguists, signal analysts, and even cryptographers began to look at the event through the lens of information theory. If it was a message, it was being transmitted over a timescale vastly different from human perception. At one pulse every 3 minutes, even the simplest of sequences would take days to form a recognizable pattern. And yet, algorithms began identifying structures, repeating rises and falls in amplitude, intervals of harmonic reinforcement, and abrupt tonal shifts. Some proposed that it might not be a message meant for us at all. Perhaps it was an automatic broadcast or a background process set in motion long ago, for a reason beyond our current comprehension. The Earth, after all, is ancient. If the origin lay deeper than known geological activity, it could predate humanity itself. Curiously, nearby rock strata began exhibiting what geologists termed phase anomalies, an odd shimmering underpolarized light when thin slices of stone were viewed under a microscope. These anomalies didn't exist in control samples taken from identical rock types a mere 50 miles away. Whatever the source of the pulses was doing, it was beginning to have a physical effect on its surroundings at the molecular level. Some minerals showed signs of accelerated metamorphism, where sedimentary rock transitioned to denser forms at rates unheard of outside laboratory environments. Temperature and pressure alone could not account for this. The shift appeared catalyzed by something invisible. At the University of Michigan, a team of mineralogists working in conjunction with national labs introduced a bold hypothesis. What if the pulses weren't merely vibrational events, but a form of energy transmission? Not electromagnetic in the traditional sense, but something akin to quantum resonance. Vibrations that interacted with matter at a subatomic level. These resonances could hypothetically alter energy states within atomic bonds, reshaping how matter behaved. If true, it could redefine fundamental assumptions in chemistry and physics. The structure beneath Ohio might not be an object in the traditional sense, but a device, an instrument, tuned to manipulate reality itself in a highly localized and precise manner. To test these ideas, synthetic crystalline matrices were built and exposed to high-fidelity recreations of the Ohio pulse waveform in controlled environments. Unexpectedly, some of the samples began to fluoresce, emitting faint glows that could not be accounted for by heat or ambient radiation. One experimental setup involving a lattice of bismuth-infused quartz showed increased conductivity along specific axes only while the signal was active. When the waveform stopped, so did the conductivity. This opened the door to entirely new theories of material science. Was it possible that materials could become temporarily tuned by resonance to exhibit new properties? And was this phenomenon a key to understanding what was buried beneath the surface? Meanwhile, atmospheric anomalies continued to accumulate. Weather patterns above the region grew increasingly erratic, not in a destructive way, but in their symmetry and timing. Cloud formations spiraled gently around invisible centers, and barometric pressure cycles aligned precisely with the pulse intervals. Radar readings showed that even micro droplets of water in the air were clustering in unusual formations, spherical rather than the usual amorphous shapes. These droplets would remain coherent for several seconds longer than expected before dispersing. Atmospheric scientists speculated that localized alterations in the electric field of the air were causing temporary shifts in surface tension behavior. Though still a theory, it suggested the pulses were exerting influence not just below, but above and into the very sky. Farther afield, the implications rippled into disciplines once considered unrelated. Cognitive scientists began studying subjects exposed to recordings of the pulses at accelerated frequencies, noting unusual responses in brainwave activity. Individuals reported vivid mental imagery, heightened pattern recognition, and, in a few rare cases, the sensation of remembering something they had never learned. The phenomenon was dubbed induced cognitive synchrony, where brain activity seemed to fall into step with external vibrational stimuli in a way that bypassed normal sensory processing. Though the ethics of prolonged exposure were debated fiercely, the notion that a frequency, just a vibration, could alter neural pathways hinted at a future where thought and environment could be synchronized through pure resonance. Back underground, the mysterious cavity showed signs of subtle expansion. LiDAR-based models, updated every week, began to detect minute shifts in the rock layers surrounding the chamber. These were not typical collapses or subductions. The cavity wasn't caving in, it was unfolding. Like a flower blooming in geological time, its internal geometry was becoming more complex. Layers of concentric rings emerged, not carved or drilled, but naturally forming as if programmed by some ancient set of instructions embedded in the stone. Each new layer had a slightly different density, suggesting that materials were being rearranged, not added but transformed. The energy fueling this change remained undetectable by conventional means. There was no measurable increase in heat, no sudden bursts of radiation, no magnetic surges. The cavity evolved in silence, pulsing steadily. It became increasingly clear that human technology lacked the tools to fully measure or replicate what was happening. This realization pushed research into uncharted territory, combining deep Earth imaging with quantum sensors, exotic material synthesis, and even gravitational waveform interference patterns to probe the core of the anomaly. Amid these efforts, an entirely unexpected discovery took the scientific world by storm. During an electromagnetic scan of the subterranean space, a repeating interference pattern was detected, not from the cavity itself, but from an adjacent area roughly 800 meters to the northwest. It was as though the main anomaly was casting a shadow, a secondary point of interaction where the waves refracted and focused. When the team drilled a narrow borehole into this zone, they found something wholly alien, a vein of metallic substance unlike any known alloy, not iron, nickel, or anything typical of terrestrial origin. The material had an iridescent sheen, a nearly perfect atomic lattice, and zero magnetic permeability. In lab conditions, it neither corroded nor conducted electricity. It simply existed, inert but flawless. Metallurgists and physicists converged to examine it, naming the substance calatherium, a nod to the Greek kalith, meaning hidden. Its properties defied categorization. It didn't respond to heat, didn't reflect infrared light, and somehow maintained a constant internal temperature regardless of environmental change. More astonishingly, when cut or polished, it emitted faint pulses of energy that matched the Ohio frequency, suggesting that the material itself was in resonance with the cavity, as if it were part of the same system. If calatherium was part of a structure, then the implications were profound. The cavity might be a node, a focal point in a network of buried elements. Perhaps it was a beacon, a conductor, or even a processor, a planetary-scale device dormant until activated by conditions no one yet understood. Was the Earth itself a host to ancient mechanisms far beyond human understanding? Could other such structures lie dormant elsewhere across the globe, waiting for alignment or resonance to awaken? The data accumulated rapidly, but consensus remained elusive. Some believed the phenomenon was a byproduct of the Earth's own processes, a rare convergence of mineralogy and vibrational harmony that had simply gone unnoticed for millennia. Others saw it as evidence of past intervention, by unknown hands, perhaps extraterrestrial, perhaps not. A growing minority proposed an even more radical idea, that the pulse was a feedback loop, not a signal sent, but one received. In this interpretation, the Earth was reacting to something external, a force or message from beyond, tuned to resonate with structures deep within the planet. Regardless of origin, the phenomenon refused to diminish. Scientists camped in mobile labs along the forest edges, vigilantly watching. Instruments hummed around the clock, recording the unchanging tempo of the Earth's strange heartbeat. Satellites circled above, watching the clouds swirl in eerie synchrony. Deep underground, the pulse moved through stone, water, and time itself. Steady, unyielding, unknowable. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Ohio's shocking event? Will scientists explain this fast? We want to hear from you. Thank you for watching and see you next time.